For today, we are going to discuss about the normal curve. We are going to understand the concept, we are going to sketch, and we will give the properties of a normal curve. And also, we are going to recognize the importance of the normal curve in statistical inferences. Good morning everyone, this is Teacher Jurel and welcome to our online class. There are a lot of events in real-life situation that generates a random variable. And those random variable has the tendency to approximate a normal distribution. For example, a teacher prepared a well-defined examination, and that exam was given to a class of 50. Upon checking, we will notice that there are few students who received very low scores, and there are few students who received very high scores. But majority of the students were in the middle of those two extreme scores. In reality, if that exam were given to a bigger number of cases, and their averages, the mean, the median, and the mode were all zeros, the distribution is said to be a normal distribution, or simply a normal curve. A normal curve plays a very important role in statistical inferences because the normal curve gives a graphical representation of the statistical values that describes the characteristics of a population and helps in decision making. These are the properties of a normal probability distribution or simply a normal curve. This is what a normal curve looks like. First, the normal curve is bell-shaped. If you will notice, the shape of the normal curve resembles a bell. Number 2, the curve is symmetrical about its center. This is the center of the normal curve. 50% of the distribution lies on the left side of the bell shape, and 50% of the distribution lies on the right side of the bell-shaped curve. Number 3, the mean, the median, and the mode coincide at the center. You will find those three averages on this broken line, the center of the normal curve. The width is determined by the standard deviation of the distribution. The center of the normal curve is the mean. From the mean, you have one standard deviations on both sides of the distribution. You have one standard deviations, two standard deviations, and three standard deviation. The deviation will tell us how wide the distribution or the normal curve is. The curve is asymptotic to the baseline. This is the baseline. And if you extend these two lines infinitely, they will just move closer and closer to the baseline but will never touch the baseline because the normal curve is asymptotic. And last, the area under the normal curve is equal to 1. 100% of the distribution lies under the normal curve. This is the center of our distribution where mean is equal to 0. One standard deviation from the mean, that's on both sides, is equal to 0.6826 or 68.26%, or that's 34.13% on one side. Next, two standard deviations from the mean is equal to 0.9544 or 95.44%, or that is 47.72% on both sides, this side and this side. And last, three standard deviations from the mean is equal to 0.9974 or 99.74%, or it's 49.87% on both sides. Those are the areas under the normal curve for every standard deviations from the mean.